Hello, this is Anthony Radamonte with Copley Controls. Today we'll be discussing trajectory sequencing. So um, let me go up here. Got this nice app note about trajectory sequencing. And so here's an example. So we have a trap move, and we want to combine these two moves into one move. Um, and so what I mean is that the first move will have a non-zero ending velocity, and the second move will seamlessly transition. You'll transition into that second move, and then eventually you'll reach the zero velocity. Or you can, continuously stream moves down to the buffer. The buffer has a max size of 8 moves that it can hold. So I'll show you a CVM implementation. But here are the parameters that we set. So in CVM, we have a move bean, and that asks for these parameters. So like here, what type of move is it? Is it a trap or a S-curve? Is it absolute or relative? And where are you going? What position, how many counts? And then the max velocity, max accel, max decel, max jerk. And then this parameter is not in the move bean, but you can use a getSet parameter bean. This is the ending velocity. So these are for trap moves only. This is not for S-curve moves. And it's the same units as the max velocity. So it's the ending velocity. And then this parameter we'll be using as well. This is the trajectory buffer. So it tells you some information about the trajectory buffer. So bits 0 to 7 give you the number of free positions in the buffer, and then 8 to 15 give you the full positions in the buffer. So I'll just be looking at this, bits 0 to 7. I want to know how many free spots there are. And then here's the values of T that you can command. So, in ASCII, of the ASCII command line, you can type T0. So T space 0 will abort any move in progress. T space 1 will start a move, assuming that you have the parameters entered in, the move parameters that we talked about. T2 will home, so it'll initiate a homing sequence. T3, that will save a sequence. So that'll save the current values of the trajectory parameters into the next free buffer location. Then T4, that starts a sequence. So you send the T4 command when you have multiple trajectory parameters. You've done this save, let's say 5 times. You have 5 different moves you want to combine. And then you hit the T4 and that'll initiate. But let's say you want to keep streaming. You don't have to keep hitting this T4. You don't want to do that. You would just send the, get your new parameters and then hit this T3, and that will just add on to the stack of the buffer. So this T4 only needs to be sent once. And then, so here's an example of just combining 2 moves. So we set the trap, and it's what is this, trap relative? Yeah, relative trap. And then we're gonna go 4,000 counts, and our max velocity is 25,000 counts per second. And then accel, decel, ending velocity is 50,000. That's 500,000. That's 5,000 counts per second. That's the ending velocity. Okay, then you send the T3 command. That'll saves that first move, and now you're ready to add on to that. So now you'd set your, so the drive isn't moving at this point. We're just loading parameters. Then we set this for the second move, 11B, 0, your ending velocity, and that's it. So just to note that the second move's max velocity equals the ending velocity for the first move. So that's just to make it so because you want to avoid spikes in your velocity transitions. You don't want to have velocities that are discontinuous, causing a bunch of problems. So finally, send the T3 command and then the T4 command. So T3 will save that, will save this second move, and T4 will start the sequence. So I've done this in CVM. We have a nice little CVM program. Let's see here, scope. I'm going to trace the profile velocity and the position. I'm just going to do the rising edge. Let's see here. Oh, event status rising edge. Then I'll do miscellaneous in motion. Might record. Okay. So yeah, here we can see that the first move that we did was 500,000 counts, 500 RPM. We could see that we got to 500 RPM, and then I set the ending velocity to be 500 RPM in 0.1 counts per second units. And then I did a trajectory save. Then I did another move step. So this move step, when you click this button here, it won't start the move. It'll just set those parameters that we need to set. So it's perfect for this application. And then so we're going to go another 500,000 counts at 800 RPM. So we're going faster now. And then the ending velocity for this move is 0. And then we save that and we start the trajectory sequence. And that's it. That's how you would set a sequence. So you can see there we don't stop. We just go on to the next move, which is really nice. But let's say that we want to monitor the buffer and we want to load all the points, all 8 moves, and do that. So I set up a program here that does that. So it'll load. It sets up 8 different moves initially, and then it'll send the trajectory start command. And then that's the only time that the trajectory start command is used, at the end of loading all the points. Then I go on to this monitor sequence, which basically will get 11C, which is the, if we go back to the app node, 11C is the status. So I'm going to be looking at bits 0 to 7 of that parameter. So here I get it, and then I do some logic, and I AND it with FF. That's a mask. So if we go in here, we type in 255. I'm ANDing it with these bits, and everything else is going to be 0, so it'll be ignored. Okay, and then saving that to R5. R5 is 0. If R5 is 0, then keep getting that parameter until we have a free space. So jump back to sequence 1, step number 1. So it'll keep getting this until finally we have a free space. R5 is non-0, then we'll go to this step, and that's going to the first move number 1. Here I'll do a math bean where I'm just using R11 for monitoring, saying that I entered this first move. And then I'm going to initiate parameters, and then I'm going to save and then jump back to the buffer monitor position. And then this continues on. So this will keep getting the trajectory buffer until we get a non-zero value, and then it'll jump to sequence 3, which is the move number 2. And then so you can see the pattern here that we just keep going back and forth and monitoring and going on to the next move. So now I'm going to save this And let me try to catch the beginning of it on the scope. So now I'm going to change the trigger to be just immediate trigger, and we'll do a continuous trace. So let's see what this looks like here. So yeah, the first move, and then it goes to the second, third, fourth, fifth, sixth, seventh, and then eighth. So that eighth move is ending in 100. So yeah, you can see how it works there, making 8 different moves. So if I want to look at the register values, you can see how many times the buffer is updating, because I put those that debugging code in, so you can see all the different moves, how many times it updates. And yeah, R5 is just the trajectory buffer that I'm using logic on. And that's it. So that's trajectory sequencing. You can do this in CVM. You can do this in pretty much any language, any language that we support. So yeah, I hope this was helpful.